Okay, so now we're going to look at the baseball salaries example, example 2.3. And if we look on our data tab, we have a lot of data. So what is in a lot of the data? The player name, the team, the position, whether or not he's a pitcher, the division, the league. If they're a playoff team in 2017, if they were a World Series team in 2017, and salary. So we have all this data, and we're going to take a look at a small portion of it. So we got a couple different questions. Sorry, I had to cough, and I didn't want to get on that on camera. So the first thing we're going to do is, we're going to do some hardcore statistical questions today. And so we're going to calculate the 3 M's, the mean, the median, the mode. Those are our central tendencies of the salary. So what is the mean? That is the average of everything. What is the median? The median is there's exactly the same amount of points on the left and the right of the graph. What is the mode? The mode is the highest instance that happens in the graph. So just normal stuff. We're going to calculate out the maximum, minimum, the quartiles, and the percentiles in part 2. Part 3, we'll do the range, the interquartile range, IQR, the variance, standard deviation, which is a measure of the variance of the salaries. And then we're going to figure out what percentage of players make at least $1 million and what percent make $3 million. And then we're going to make a couple of graphs. We're going to do a histogram and a box plot, and then we're going to talk about which one's better and whatnot. So let's go. We're going to start out here in answers. We've already kind of have a framework set up. And so let's just dive right into it. So how do we find the mean? Another name for the mean is the average. We can use the average function. And we're going to go over to our data. And so we're dealing with salary. So that is going to be column J. And we're going to click and we're just going to drag down. And we've got 878 data points. That'll be a good thing to remember. And we're just going to close that out. And so our average is $4.5 million-ish. So that is, take all the instances, add them up, divide them by the number of instances. So the next thing is the median. And so we're going to figure out at what point are we where we have the same number of instances on the left as the right. And so median, and there we go. It's another Excel function, and we're going to do the same thing. And even though I started dragging from the bottom to the top, it orders them correctly, and I did that because I want to just type in 2, because that is where the data starts. And there we go. So the median salary, 1.4 mil. That means that half the players make under that, half of them make over that. And so now we want to look at the mode. And the mode is going to be, it's going to give us the count of what is the most common instance that happens. Actually, I'm just going to grab that data because I'm going to look at that again. Now, normally, and especially, I stress this a lot when I teach 690, I would have named that data something. But we're not dealing with that now, so maybe we'll do that in another example. So we're going to do the mode. And actually, here we go. Mode returns the most frequently occurring or repetitive value in the field. So that's our mode. So we're just going to give it the data. And I accidentally fat-fingered that there, so we're going to get rid of that. And so the mode. So 545,000 happens more often than any other one. What do these numbers mean? Mean is significantly higher than our median. So the median's, if this was 0 to here, the median would be over here. The mean is over here. And so that means that we are skewed. And that would be what we would call a right skewed distribution. Because even though it's on the left, it's got a longer tail on the right. And I'll show that when we get down to the graph. Actually, it'll be easier to talk about there. So the median is significantly higher, so it is skewed. The mode really isn't a good measure of the central tendencies here because 545 is the league minimum, so that's like 0. So the mean is significantly higher by about 3 times, which tells us that we have a right skewed distribution. And so once again, we'll talk a little bit more about skew when we get down to the graph and what those mean. Okay, so we're going to go through here. And in fact, you know what? Let's go back because we're going to be using this data a lot. I'm going to give this all a name. So I'm going to highlight all of this stuff. In fact, I'm going to highlight with the salary because we're going to use that salary. I'm going to highlight everything here, including salary. I'm going to go to data. And actually, I always screw that up. I'm going to go to formulas, go create from selection, say top row. And so now what that's done is if I highlight all this, you'll see that it's given that name salary because it took it from that top thing. See up here, it says salary. So it's going to make things easier for us. So if I come in here, instead of using data, I can type in salary. See the little thing pops up to say, hey, I know that word. Put in salary, and you get the exact same thing. We're going to use that quite a bit through here just to make things easier so I don't have to keep typing in J2 to J878 and whatnot. So what's the minimum salary? We get the function min, and we'll use salary because we put that together. So the minimum salary is $5.45. We knew that was going to happen. Let's go and do the other side here. We're going to do the max. So the max function gives us the maximum, and we're going to do that over the salary range. So the max salary is $34 million. Man, I got into the wrong profession. And so now we're going to do percentiles. And so this is what that's what this guy here is for. That's 1%, 5%, and then we'll do the percentages first, and then we'll go back to, we'll do the middle ones here, which are the quartiles. So percentage, how do we do this? Equals percentile. And I am awful at spelling, so we want to use this one right here. Returns the kth percentile in a range. So we're going to use percentile. And so array. Well, the array that's going to be looking for is we're looking at our salary data. So we're going to go for our salary, and then it wants to know what K is. So K being what is that percentile. So first percentile, fifth, da 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 da. Of course, I can't click on this here, so I could type in, I know it's C13, or I'm going to use my right button on my thing, which isn't going to work for me for some reason. So I'm going to click over here, and I'm going to use the left arrow to move it to C13. And so there we go. I'm going to close that out. And so the first percentile on our distribution, if we look at our thing all the way at 1%, is going to be 545. So I want to do the same thing here for the fifth. And you know what? Since I've got that salary locked in, I'm going to drag that all the way down. I'm going to have it do everything for me. These ones don't matter because they're actually quartiles. I'm going to delete that. Why do I have a number error here? Because it's 2 would be 200% in percentile. So it's like, wait, there's no actual number there. That's what the number error is. So we're going to get rid of the quartiles here. But then we get to the 95th percentile of salary. And so basically, if we just looked at the thing, went all the way to 95%, well, that's going to be 19 million. 99th percentile would be 27. And the maximum would be the 100th percentile. So we go all the way up to 100. That gives us our maximum value. So those are just the percentages. Another way to think about it is fifth percentile. That means that 5% of all the salaries are below 545. 95th percentile tells me that 95% of all the salaries are below 19.5 million. Okay, so we'll do quartiles. And once again, quartiles broken up into quarters. So the first quartile is the exact same thing as the 25th percentile. So quartile, once again, I'm going to go here because I can't spell. So the array, our array, we gave it that salary name. We'll use salary. Quartile. Look at that, 0, first quartile, median, or the second quartile, third quartile, 4. It's all telling you what's going on. Once again, I'm going to pick, because I have that 1 there, we can't see that right now. Close the thing, and that gives me the first quartile, so the 25th percentile. And the reason I did it this way, so I can drag it down since I have those in there. Da, da, da. So the second quartile, or the 50 percentile, means that 50% of all the salaries are below 101.4 million. Notice it's the exact same as the mean. the median, which is what it should be, because the median, you have exactly the same amount on one side as the other. Okay, so there we go. And that's how we get the min, max, quartiles, and percentiles. And so go back to the prompt here, what did it actually say? The second quartile is equivalent to what value we calculated? Well, second quartile is equivalent to the median, which is what it should be, since the second quartile is 50%. Okay, so we're going to look at our measure of variability. So if we go back to the prompt, what did it actually want? Calculate the range, the interquartile range, the variance, and the standard deviation of the salary. What are the units of range, IQR, variance, and standard deviation? Well, let's go calculate those first. And so the range is, what is the range? The range is the minimum to the maximum. So you can just take the max value, subtract the minimum. I could type the equation in, but since I've already calculated, I'm just going to take the maximum. I'm going to subtract the minimum, and done. So the range is 33,500,000, That means that that's how many data points there are between the maximum and the minimum. Okay, the next part is our interquartile range. So the interquartile range is the distance from the third quartile to the first quartile. So what are we going to do? We're going to go and take our third quartile. We're going to subtract our first quartile. So the 75%, the 75th percentile minus the 25th percentile. What does that do? That gives us the middle 50% of our data. And there we go. Interquartile range, 5.4 million. Okay, and so now we get into our variance. So our variance is that statistical equation where we are taking our instance and we're subtracting it from the mean, we're summing it up, we're dividing by the total counts, and that is a lot of fun to do by hand. Guess what we're not doing by hand? Because we have Excel. So we're going to go right into variance. Now we have a couple of different options for variance, and we have var.p, which gives it to the population, and we've got var.s, gives it to us by the sample. We are going to be doing it based on the sample, so we're going to be ignoring text and logical values in there, and that's fine. Once again, we already named that range salary, so let's use that, because I won't need to do anything else. And so that tells us the variance is 3.88. Now see where it says E plus 13? That is shorthand. We use it a lot in engineering, and basically E plus 13 means times 10 to the 13th power. The variance is a really big number. So let's look at the standard deviation. Now standard deviation, once again, that's basically the variance squared. It's a better measure of what's going on, and it's ST-dev is standard deviation. Once again, we have a bunch of different options to go, and typically we want to look at the standard deviation of the sample, so stdev.s. So it gives us a more accurate measure, and so then we go salary because we have set that block up. And I misspelled salary because, of course I did. Fortunately, it gives us that little tip that pops up, so it helps me correct my bad spelling. And so the standard deviation of the salary, so the square of that error from the mean, is going to be 6.2 million. Now, the other part it asked me is what units is us all in? Well, as you can see, the range, the interquartile range, and the standard deviation all have the same units as the original data, which in this case is dollars. Variance does not have a dollar sign in front of it. Why is that? Well, because remember, variance is a squared value. If you go back to that, our statistical data, it's going to be units squared, so it's going to be the dollars squared, which obviously we're not going to have. Standard deviation is the square root of that, so that's why it goes away. Units are really important, so we keep beating those in. Okay, and so in the next video, we will take care of the rest of the problem.